Hello everyone, myself Aruna, working as lecturer in Department of Computer Science and Engineering. I welcome all you to the session 13 in the Unit 2 Logic Circuits. In this session, we'll have brief discussion on the topics called as synchronous counter and 4-bit synchronous up-down counter and applications of the counters, and finally we'll have a look on different types of MCQs with respect to these topics. First, we'll see what is synchronous counters. Synchronous counters are also used for the counting purpose. For every clock pulse, input clock pulse, the contents of the counter will be incremented by 1, then output will be incremented by 1. Then it reaches the last state, the output value will be wrapped back to the initial stage. Here in the synchronous counter, clock pulse is applied to all the flip-flops simultaneously or at a time or in parallel. Clock pulse will be fed. So, because of this, the ripple problem present in the asynchronous counter will be eliminated. These synchronous counters are made up of or constructed or designed using the JK flip-flops. And the JK inputs will allow the flip-flop status to change or to toggle from one state to the another state by enabling or disabling the various stages of count. And because of the elimination of the ripple problem in the synchronous counter, it is more reliable counter because without the failures, much failures won't occur, malfunctions won't occur in the synchronous counter. So we can reliable this circuit for the counting purpose without any fault or the mistake. And that too, these counters, asynchronous counters, works with a high speed of clock, because for every flip-flop or for all the flip-flops, clock pulse we will provide simultaneously or at the time. This is about the synchronous counters. Please remember, in the synchronous counters, clock pulse will be given to all the counters simultaneously or at a time. So it is a reliable circuit and operation speed is more. Now we'll see how the 4-bit synchronous up-down counter works. As the name itself indicates, 4-bit. That means it should consist of 4 flip-flops. 4 flip-flops, and it should count up to 16 states, that is from 0 to 15, because to rise to the power of 4 bits, here 4 bits, no, for the 4 to rise to the power of 4 is equals to 16. It should count from 0 to 15. And this 4-bit synchronous counter, we should give clock to all the flip-flops simultaneously. And this 4-bit synchronous counter should be designed in such a way that this contents of the counter should be incremented by 1 for every clock pulse, every clock pulse. Okay, if the contents of the counter will be incremented by 1 for every clock pulse, that type of counter we can call it as up counter. Up means incrementing by 1. Next, similarly, if the contents of the counters are decremented decremented by 1, then the type of counter we can call it as down counter. If it is incrementing by 1 for every clock pulse the contents, then that counter we will call it as up counter. For every close, if the contents are decremented, that counter we can call it as the down counter. This 4-bit synchronous up-down counter should work in both the modes. It should count upwards and also it should count downwards. If the counters capable of working both in the count up mode and the count down mode, combinedly those counters we can call it as up down counters. Because ಇದು ಅಪ್ ಮೋಡಲ್ಲೂ ವರ್ಕ್ ಆಗುತ್ತೆ, ಕೌಂಟಿಂಗ್ ಅಪ್ಪು ಆಗುತ್ತೆ, ಕೌಂಟಿಂಗ್ ಡೌನು ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ಒಟ್ಟಿಗೆ ನಾವು ಇದಕ್ಕೆ 4-bit ಸಿಂಕ್ರೋನಸ್ ಅಪ್ ಡೌನ್ ಕೌಂಟರ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ ಲೆಟ್ us study about these individual up counter and the down counter, and finally we'll see how these up and the down counter will combinedly work in the single circuit. Now let us start with the up counter. Up counter means the contents of the counter should be incremented by 1 for every clock pulse. 15 states are there. 15 times it should increment. Okay, for each clock pulse, every time it should increment. Let us see here. The up counter should increment the binary values in this mode. To construct this or to design this circuit to count up in this mode, let us observe the patterns of the values of Q0, Q1, Q2 and the Q3. The first column is output values is named as Q0. The second column values are named as Q1. The third values are named as Q2. The fourth values are named as Q3. Let us see. Q0 is the output of the first flip-flop. Q1 is the output of the second flip-flop. Q2 is the output of the third flip-flop. Q3 is the output of the fourth flip-flop. Next, all the inputs have been joined and that will be connected to the power supply, high power supply in the flip-flop 1. Flip-flop 1. Let us observe this pattern once again. I'll repeat this one. Q0 changes its state for every clock pulse. Toggles 0 idre 1 agutte, 1 idre 0 agutte. Next, Q1 changes its state from 0 to 1 or 1 to 0 whenever Q0 value will be 1. Next, Q1 changes its state from 0 to 1 or 1 to 0 when both Q1 and the Q0 values will be high. Next, Q3 changes its state from 0 to 1 or 1 to 0 whenever Q0, Q1 and the Q2 values will be high. Let us, keeping this in mind, will construct the 4-bit synchronous up counter to count in this fashion. Here 4 flip-flops are required. 4 flip-flops are there. For each of these flip-flops, we are giving the clock pulse simultaneously or in parallel or at a time. And for the first flip-flop, J and the K inputs have been joined, and for that power supply, V power supply is given. For the first type, as the power supply is applied, this way always it will be in the 1. ಇದು ಯಾವಾಗ 1 ಇರುತ್ತೋ J and the values, J and the K values will be 1. If the J and the K values will be 1, as we all know, the state of the flip-flop JK flip-flop will be toggles from 0 to 1 or 1 to 0. If both the J and the K values are 1 because it is connected to the high power supply, J and the K values will be 1. If the J and the K values will be 1 means the flip-flop will change its state from 1 to 0 or 0 to 1. Then Q0 will be either 0 or 1. Initially it is 0. It will change from 0 to 1. Then for the next clock pulse, it will change from 0 to 1. Next it will change from 1 to 0. For every clock pulse, it will change its state from 0 to 1 or 1 to 0 because JK flip-flop future ಏನು ಅಂತಂದ್ರೆ JK ಎರಡು ಒಂದಾದಾಗ it should toggle. It should toggle. ಅದಕ್ಕೋಸ್ಕರ ಟಾಗಲ್ ಆಗಬೇಕು ಅನ್ನೋದಕ್ಕೋಸ್ಕರ we have connected to the high voltage power supply ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ. ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ ಕೊಟ್ಟಾಗ ಇದು ಚೇಂಜ್ ಆಗುತ್ತೆ. Q0 ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ let us observe Q1. Q1 is the output of the second flip-flop. If you want to the Q1 values, it should depend upon the Q0 values ಅಂತ ಹೇಳಿದೆ. ಯಾವಾಗ Q1 ಟಾಗಲ್ ಆಗುತ್ತೆ, ಚೇಂಜ್ ಮಾಡುತ್ತೆ, 0 ಇದ್ರೆ 1, 1 ಇದ್ರೆ 0, the Q0 ವ್ಯಾಲ್ಯೂ 1 ಇದ್ದಾಗ. Q0 ವ್ಯಾಲ್ಯೂ 1 ಇದ್ದಾಗ ಅಂತಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ವಿ ಕ್ಯಾನ್ ಕನೆಕ್ಟ್ Q0 ವ್ಯಾಲ್ಯೂ ಟು ದ JK flip-flop. JK flip-flop inputs of second flip-flop JK input values ಗೆ ನಾವು Q0 ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ ಅಂತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಸ್ಟೇಟ್ ಆಫ್ ದ flip-flop will be changed because ಇಲ್ಲಿ 1 ಇದ್ದಾಗ, ಯಾವಾಗ ಇಲ್ಲಿ 1 ಅಂತ ಇದು ಬಂದಾಗ ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ 1 ಬರುತ್ತೆ. 1 ಬಂದಾಗ JK flip-flop ಸ್ಟೇಟಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಚೇಂಜ್ ಆದಾಗ ಔಟ್ಪುಟ್ ವ್ಯಾಲ್ಯೂಸ್ Q ಮತ್ತೆ Q ಬಾರು ಚೇಂಜ್ ಆಗುತ್ತೆ. Then automatically Q1 will be changed. So we have connected Q0 value to the combined of J and the K. Next, so we didn't require any other gates here. Directly we can connect Q0 to JK inputs of the second flip-flop. So whenever Q0 value will be 1, it changes its states from 0 to 1 or it changes its state from 0 to 1 or 1 to 0. Either it may change from 0 to 1 or 1 to 0 whenever the Q0 values will be 1. Next, similarly, Q2 values we need. Q2 is the output of the third flip-flop. This flip-flop should change its state whenever this clock as well as the JK inputs will change. That means this flip-flop should toggle or change its state only if Q1 and the Q0 values will be high. According to this, let us observe here, Q2 will change its states from 0 to 1 when both Q0 and the Q1 values will be high. ಎರಡು ಹೈ ಇರಬೇಕು ಅಂತಂದ್ರೆ here we require the AND gate because in the AND gate output will be high only if both the inputs are high. ಎರಡೂ ಇನ್ಪುಟ್ ಹೈ ಇದ್ರೆ ಮಾತ್ರ ಔಟ್ಪುಟ್ ನಮ್ಗೆ ಹೈ ಬರುತ್ತೆ, ಅಥವಾ ಎರಡೂ ಇನ್ಪುಟ್ 1 ಇದ್ರೆ ಮಾತ್ರ ನಮ್ಗೆ ಔಟ್ಪುಟ್ 1 ಬರುತ್ತೆ. AND ಗೇಟ್ ಅಲ್ಲಿ if any one of the inputs are 0, we will get 0 here. ಅವಾಗ ಇದು ಸ್ಟೇಟಸ್ ಚೇಂಜ್ ಆಗಲ್ಲ. ನಮ್ಗೆ ಕಂಪಲ್ಸರಿ ಇದು ಸ್ಟೇಟ್ ಚೇಂಜ್ ಆಗ್ಬೇಕು ಅಂತಂದ್ರೆ ಜೆ ಮತ್ತೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಕಂಪಲ್ಸರಿ 1 ಆಗಿರ್ಬೇಕು, ಕ್ಲಾಕ್ 1 ಆಗಿರ್ಬೇಕು. ಜೆ ಕೆ ಮತ್ತು ಎರಡು 1 ಆಗಿರ್ಬೇಕು ಅಂತಂದ್ರೆ ಇದಕ್ ಬರ್ತಿರುವಂತ ವ್ಯಾಲ್ಯೂ 1 ಆಗ್ಬೇಕು ಅಂತಂದ್ರೆ ಕಂಪಲ್ಸರಿಲಿ ವಿ ರಿಕ್ವೈರ್ ದ ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ 1. ಅದಕ್ಕೋಸ್ಕರ we have inserted one AND gate here for fetching the output values from the first flip-flop and the second flip-flop. The two high input values. Okay, so Q0 is connected as the first input value for this AND gate. Next, Q1 will be connected as the second input value for this first AND gate. If both Q1 and the Q0 are high, then it produces the high input value and this passes that high input values to these inputs for the third flip-flop. If the both J and K are in the high, automatically the flip-flop, third flip-flop status will be changed. 0 ಇದ್ರೆ 1 ಅಥವಾ 1 ಇದ್ರೆ 0 toggle ಆಗತ್ತೆ. Then Q2 value will be changed. So we have connected AND gate here. Next we want the output for the Q3. Q3 is the output from the fourth flip-flop. Fourth flip-flop. This should change or toggle its state whenever J and the K value will be 1. ಇದಕ್ಕೆ 1 ಬೇಕು ಅಂತಂದ್ರೆ, ಇದು ಚೇಂಜ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ, we require the output values of Q2, Q1 and the Q0 accordingly this. ಯಾವಾಗ ನಮಗೆ Q0, Q1, Q2 values ಹೈ ಇದ್ದಾಗ ಅಷ್ಟೇ ಲಾಸ್ಟ್ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ದು status or the state will change or toggle from 0 to 1. So here we have inserted one more AND gate. For this AND gate, we have taken the inputs from the Q0 and Q1. Already for the Q0 and the Q1 is connected to this AND gate, we will get the output from here that is connected as first input to the second AND gate. Next input or the second input for the second AND gate is from the third flip-flop. So this flip-flop will change its state whenever Q2 and the Q1 and the Q0 values will be 1. Okay, it gets that values. If all these values are 1, output of this AND gate is 1. Then it toggles or it changes its states. Then Q3 value will be changed. So here to construct the up counter according to this logic, we need two AND gates. Two AND gates to toggle. This flip-flop does not require any AND gate because already it is connected to the high supply. This flip-flop toggles on every clock pulse. Then this flip-flop toggles only if Q0 is high according to this. ಯಾವಾಗ Q0 value high ಇರುತ್ತೋ ಅವಾಗಷ್ಟೇ toggle ಆಗುತ್ತೆ. Next, this flip-flop toggles only if Q0 and the Q1 will be high. Q0, Q1 will be high. Then the last flip-flop, that is the fourth flip-flop, will toggles only if Q0, Q1 and the Q2 will be high. To make it as high JK flip-flops, we have connected the AND gates. Okay, this type of circuit, 4-bit synchronous circuit, will counts in the upward direction. The contents of the counter will be incremented by 1 for every clock pulse or every clock signal. So this counter we will call it as up counter. Next, let us start with a down counter. As the name itself indicates, down counter means the contents of the counter should be decremented by 1. That type of counter we can call it as the down counter. The content should be decremented for every clock pulse. For every clock pulse. Here also the 4-bit synchronous counter is having 4 flip-flops. 4 flip-flops, and it should count, or it should cross the stages from 0 to 15, because 2 raised to the power of 4 is 4 flip-flops are there, 16 states. That means 0 to 15. Let us observe this truth table. It is counting in the downward manner. So it is decrementing the contents by 1, 15, 14, 13, then 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If it reaches to the last state, it should wrap back to the 0th state. The contents of the counter is decrementing by 1. So, we can call this counter as a down counter, which construct the circuit diagram according to this. Let us observe here the Q0. It is decrementing downwards. For that purpose, we will put it as bar here. Let us observe the Q0 values. Here, Q0 values will be changing. Q0 bar values will be changing for every clock pulse. Toggles for every clock pulse. 1 idre 0 aitu, 0 idre 1 aitu. Itara for every clock pulse, the values keeps on changing. Next, let us observe the Q1 values, Q1 bar values. Here, Q1 changes its state or toggles whenever Q0 value will be 0. Q0 value 0 iddaga, it changes its states from 1 to 0. See here, observe here, next illi 0 iddaga, illi 0 inda 1 aitu, next illi 0 bandaga 1 irodu 0 aitu, next illi 0 bandaga 0 irodu 1 aitu, illi 0 iddaga 1 irodu 0 aitu, next illi 0 bandaga 0 irodu 1 aitu, next illi 0 bandaga 1 irodu 0 aitu. Okay, next in this fashion the toggles will change. Next, the Q2 will change its state whenever both the Q1 and the Q0 values will be 0, 0. Q0 ಮತ್ತು Q1 values ಯಾವಾಗ 0, 0 ಇರುತ್ತೋ ಆಗ Q2 values will change from 1 to 0 or 0 to 1. ಇಲ್ಲಿ ಎರಡೂ 0, 0 ಇದ್ದಾಗ Q1 1 ಇದೆ, ಅದರ ವ್ಯಾಲ್ಯೂ ಏನು ಚೇಂಜ್ ಆಗಿದೆ? 0 ಚೇಂಜ್ ಆಗಿದೆ. ನೆಕ್ಸ್ಟ್ ಎರಡೂ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ 0 ಇದ್ದಾಗ ಇಲ್ಲಿ 0 ಇರೋದು ಏನಕ್ಕೆ ಚೇಂಜ್ ಆಯಿತು? 1ಕ್ಕೆ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಎರಡೂ ವ್ಯಾಲ್ಯೂ 0 ಇದ್ದಾಗ Q1 ವ್ಯಾಲ್ಯೂ changed from 1 to 0. Next, let us observe the Q3 pattern. Q3 status ಯಾವಾಗ ಚೇಂಜ್ ಆಗುತ್ತೆ? Whenever Q0, Q1 ಮತ್ತೆ Q2 ವ್ಯಾಲ್ಯೂ 0, 0, 0 ಇದ್ದಾವಾಗ ಏನಾಗ್ತಾ ಇದೆ? 1 ಇರೋದು 0 ಆಯ್ತು. In the previous counter, that is up counter, toggles based on the high input values. ಒಂದಿದ್ದಾಗ ಟಾಗಲ್ ಆಗ್ತಿತ್ತು. ಇಲ್ಲಿ 0 ಇದ್ದಾಗ ಟಾಗಲ್ ಆಗ್ತಾ ಇದೆ. 0 ಇದ್ದಾಗ ಟಾಗಲ್ ಆಗ್ತಾ ಇದೆ. ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಈ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ನಲ್ಲಿ ದ Q bar, the next input, this is the first input, this is the second input of the JK flip flop. ಈ second input to Q bar values ನ ತಗೋಬೇಕು. We need to consider, because if it is 1 ಅಂತಂದ್ರೆ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಬರೋದು 0. ಇದು 0 ಅಂತಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಬರೋದು ಇದು 1. Opposite of this, 1 ಗೆ opposite to 0. So we need to consider this input for the flip flop. For the first flip flop, output is Q0. ಈ Q0 ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ, as we all know, JK flip flop should toggle. ಇದು ಟಾಗಲ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ we need to make both J and K as high. For that purpose, these two inputs have been combined and that is connected to the high power supply. That is, we can name that as VDD. Then input clock pulse is applied to all the flip-flops simultaneously. Here in this flip-flop, Q0 value will be changed. Q0 value will be changed from 0 to 1 or 1 to 0 toggles whenever both J and the K values will be high. So automatically if it is VDD is 1 ಅಂದಿದ ತಕ್ಷಣನೇ 1 ಇರೋದು 0 ಆಗುತ್ತೆ, 0 ಇರೋದು 1 ಆಗುತ್ತೆ, 1 ಇರೋದು 0 ಆಗುತ್ತೆ, 0 ಇರೋದು 1 ಆಗುತ್ತೆ. Similarly it toggles on every clock pulse. Q0 value ಬಂತು. Next we need the value from the second flip-flop. Second flip-flop the output value ಏನು? Q1 bar. This is the Q1 bar output. This Q1 bar output will change whenever Q0 bar will be in the 0th state. 0 ಇದ್ದಾಗ. ಅದಕ್ಕೆ ಇಲ್ಲಿ 0 ಬಂದಿದೆ ಅಂದ್ರೆ directly if we connect 0 to this flip-flop, 0 to this flip-flop ಅಂತಂದ್ರೆ 0 bar ಅಂತಂದ್ರೆ ಇಲ್ಲಿ 1 ಆಗುತ್ತೆ. ಯಾವಾಗ ಇದು 1 ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ automatically it changes its states from 1 to 0. So directly we will connect the output from the first flip-flop to the second flip-flop. Then Q1 bar will change its state from 0 to 1 or 1 to 0 whenever Q0 bar will be 0. Q0 bar will be 0. And to get 1 to this AND gate, okay, we'll derive that first output from the Q0 bar has a first input and second input for this first AND gate is Q1 bar. It takes the output from these two and it will send that output has an input and it will send this output as a input to has the clock pulse or for the JK inputs for the third clock pulse. This flip-flop toggles only if Q0 and the Q1 bars will be high. ಇವೆರಡು ಹೈ ಅಥವಾ ಇವೆರಡು ಲೋ ಇದ್ದಾಗ ಇದರ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗುತ್ತೆ. Then this flip-flop it toggles or it changes its state whenever Q0 and the Q1 and the Q3 will be 0. ಅಲ್ಲಿ 0 ಇದ್ದಾಗ this values will be negative bubbled. ಇಲ್ಲಿ ಯಾವಾಗ 0 ಬರುತ್ತೋ ಆ ವ್ಯಾಲ್ಯೂಸ್ ನ ನೆಗೆಟಿವ್ ಬಬಲ್ ಮಾಡು ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. ಇಫ್ ಯು ಪಾಸ್ ದೀಸ್ ಟು ದ ನೆಗೆಟಿವ್ ಬಬಲ್ಡ್ ಅಂತಂದ್ರೆ ಆ ನಾಟ್ ಗೇಟ್ ಗೆ ಕಳಿಸಿದ್ರೆ ವಿ ವಿಲ್ ಗೆಟ್ ದ 1. ಹಿಯರ್ ಆಲ್ಸೋ ಇಲ್ಲಿ ಹೈ ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ ಆಲ್ರೆಡಿ ಇದೆ, ಇಲ್ಲಿ 1 ಇದೆ, ಆಟೋಮೆಟಿಕಲಿ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ 1. This value will be 1. Then if the value of this J and the K are 1, then this flip-flop will change its state from 1 to 0 or 0 to 1. Then we'll get the values of Q3. Here, let us observe here. Whenever the values are 0, Q0 value 0 idavaga Q1 value change agutte. Then Q1 value will be changed when Q0 value will be 0. Then Q2 value will be changed when both Q1 and the Q0 values will be 0, 0. Okay, we have attached two AND gates here below because here counting is performing in the downwards and this flip-flop status will be changed by taking the 0 values for the output values in the output values. So the first flip-flop toggles on every clock pulse. This flip-flop toggles only if Q0 value will be high. Q0 value will be high. 0 idre automatic agi bubble ಮಾಡಿದಕ್ಕೆ high ಬರುತ್ತೆ. Next, this flip-flop toggles only if Q0 bar and the Q1 bar will be high. Next, this flip-flop toggles only if Q0 bar and the Q1 bar and the Q2 bar will be high. If we combine these two circuits together, jointly, then we will call that as a synchronous up-down counter. Let us observe this circuit. 4 flip-flops are there, the two JK flip-flops, and in between these JK flip-flops, in the upper part 3 AND gates, in the lower part 3 AND gates, in between 3 OR gates are there. Here in this circuit, both the up counter AND gates, down counter AND gates, both have been merged together, joined together. And these AND gates output further will be passing to the OR gate, because it should count either in the upward direction or in the downward direction. These upper AND gates and both the lower AND gates are connected to the common signal called as up/down bar. So, if this circuit works in both in the upward direction as well as the downward direction, based on the signal called as up/down bar. And for the first flip-flop, the JK will be connected to the power supply called as VDD. And first, let us observe how this circuit works. If the up bar down signal is equals to 1, then upper AND gates will be enabled. Then the circuit, the 4-bit synchronous counter circuit will increment the contents by 1, because upper AND gates are connected to the Q outputs of the flip-flops. So it will count in the upward direction. For every clock, the contents of the counter will be incremented by 1 according to the logic we have seen in the up counter. Similarly, if the up/down bar signal is equals to 0 means then up is equals to 0, down bar is equals to 1. Then down bar is equals to 1 means the signal will come here. The signal will come here, then 0 bar means then lower AND gates will be enabled. This signal has to be inverted for enabling the lower AND gates. For that purpose, we will connect the NOT gate here. And also, these outputs will be bubbled here, because these AND gates will be enabled for only the high inputs. To get the high inputs, it has been bubbled here and bubbled here also. So, whenever the up or the down bar signal is 0, lower AND gates will be enabled, then the counter will count in the downward manner. That is, counter contents will be decremented by 1. Okay, it should work accordingly up or the down. Jointly both up counter as well as the down counter should work, either the up counter or the down counter. For that purpose, either this should work or this should work. We have attached OR gate here in between these two up or the down AND gates, depending upon the signal called as up/down bar. If the up or the /down bar is 1, upper AND gates will be enabled. the counter will count in the upward direction. If the up or the down counter is 0, lower AND gates will be enabled. It will be count in the downward direction. This is how 4-bit synchronous up-down counter will work. This can be written in the simplified manner in this fashion also. Here we have elaborated that have been taken and ಚಿಕ್ಕದಾಗಿ ಮಾಡಿ ಇಲ್ಲಿ ಬರೆದಿದ್ದೀವಿ ಅಷ್ಟೇ. This is another form or the short form of this one. ಇಲ್ಲಿ ಬ್ರಾಡ್ ಆಗಿ ಹೊರಗಡೆ ಹಾಕಿದೀವಿ ಹ್ಯಾಂಡ್ ಗೇಟ್ಸ್ ನ ಇಲ್ಲಿ ಒಳಗಡೆ ಹಾಕಿದೀವಿ ಅಷ್ಟೇ. 1 is equal to up counter, 0 is equals to down counter. Now let us see the two table of the 4-bit synchronous up down counter. This is upward part, this is downward part. Already we have seen this part in the up counter and the down counter individually. In the up down counter, it should work in both the up mode and the down mode. If the up is equals up or down signal is equals to 1, it should count in the upward direction 0 to 15. Next, if the up or the down bar signal is equals to 1, it should count in the decrement. The contents of the counter is decremented by 1. This is the output from the 4-bit synchronous up-down counter. Till now, we have seen the concept of the synchronous counters and the synchronous up-down counter. Next, we'll move on to the application areas of the counters. In which areas these counters will be used. These counters will be used wherever we require the conversions from analog to digital and digital to analog conversions are required. And these counters can also be used as a frequency dividers. As I explained you in the previous session, asynchronous ripple counter, the clock input signal, it is been divided into off that frequency. So, wherever that frequency division is required, in that place we can use counters as frequency dividers. Next, these counters can be used in the banking also for keep track of the counting. And also it is used in the auto parking place to keep track of the counting. Next, it is also being used in the digital clock that displays hours, minutes, seconds. There also time has to be keep track by counting. There also we need to use the counters. Counters can be used. These are the different application areas where the counters can be used. Till now, we have seen the concept of the counters and its applications. Next, we'll move on to the multiple choice questions that may appear in the activity or the quiz. Under that, the first question is in synchronous counters, the clock pulse is applied to all flip-flops. Dash, they may give dash. Okay, here, as we all know, the synchronous counter clock pulse is applied to all. So, correct answer is all. Next, in the second question, up-down counter is a combination of dash. It is a latches, or it is a flip-flop, or it is up counter, or it is up counter and the down counter. As we all know, up down counter, it is a combination of both the modes, up mode as well as the down mode. It should count both in the upper direction or it is in the downward direction. So we can call it as a up down counter. So the answer is D, up counter and the down counter. The next question is, up down counter is also known as dual counter, multi counter or multi-mode counter and the two counter. Let us think in which way we can call this. This up down counter works in dual mode, that is in two modes. One is in the up one, another one is in the downward direction. So we can call this counter as up down counter. So the answer is dual counter. Next question is, in a up counter, each flip-flop is triggered by dash. Each flip-flop is triggered by dash. The first answer is the output of the next flip-flop, the normal output of the preceding flip-flop, the clock pulse of the previous flip-flop, then the inverted output of the preceding flip-flop. In the up counter, each flip-flop is triggered by the normal output of the preceding flip-flop. Recall the up counter of the topics. The previous contents of the output Q output will be connected to the next flip-flop, that is normal output. So the answer is normal output of the preceding flip-flop. Next, the last question is, in down counter, each flip-flop is triggered by dash. The answers are the output of the next flip-flop, the normal output of the preceding flip-flop, the clock pulse of the previous flip-flop, the inverted output of the preceding flip-flop. Let us recall the down counter part. Previous flip-flop Q dash value or the output value will be connected to the next flip-flop J and K values. And once again, that is in the inverted form. So the answer is the inverted output of the preceding flip-flop. So the answer is D. These are the different types of questions that may appear in your activity or the quiz part. Till now, we have seen the concept, discussed the concepts of synchronous counters, that is synchronous up-down counter, and the applications of counters. Thank you.